have, we're going to talk first, because this is going to be very helpful as we go along, is finding the height, okay? Determining the height of a triangle. And that's a big and I will talk about the height. So some students always think you always think of your classic triangle, right, where you have a right triangle. In this case, this would be the base, this would be the height. Right? The height would go along. So the height is actually part of the triangle. It's a side of the triangle, right? And then you have a triangle like this, obtuse, right? The base is still here. Where's the height located in this case? It's not part of the triangle, but it would be measured straight down to the ground at a 90, right? So the height is there, okay? And then you have a triangle like this, where this is still the base, and the height is in the inside, right? It's on the inside of this triangle. I guess I should write base, right? So base is always there, and but the height could be part of the triangle. It could be outside or it could be inside, okay? And also another variation would be if it's a flipped triangle, right? A lot of students don't think of the height as going down, right? And it's still, this is your height here. This is the base, this would be the height. So when you get a triangle, the base is going to be perpendicular to the height. You have to remember that. Like, they always meet at a 90. No matter what, the base and the height always meet at a 90. And you might think, well, Mr. Dirksen, the base is not even touching the height here, but you could tell that it's these two, right? If you were to extend the base, they would meet at a 90. And so that's what you're looking for. So if I ever ask you for the area of a triangle, right? Remember, it's base times height divided by 2. No news there, but from time to time that shows up. And so just remember and this is why finding the height is going to be important, because they might ask for it straight out, or you might need it to find the area of the triangle, okay? I will first give you an example, and then I'll generalize from there. So, example, determine the height of triangle XYZ. Yeah, if you ever need to get my attention, if you're trying to type something, just raise your hand a couple of times, okay? Then I will notice that you're trying to say something. Okay. So let's draw it. And I'll purposely make it off-centered so it's not I don't want it to be an isosceles triangle, okay? So like that, and then you just go X, Y, Z. And I'll tell you this, it doesn't matter where you put the X, Y, and Z. I'm not picky with that. So if you go clockwise, counterclockwise, it doesn't really matter. It won't change things as long as you're consistent, okay? So how about, yeah. So we'll say that this side down here is 6.48 inches. This angle right here in this corner, angle X is 46. And this one on this side is 29. Okay. So then how about this? Let's say the diagram was not provided. They would say that angle X is 46 degrees. Side Y is going to be 6.48 inches. And side angle Z is going to be 29 inches. So how do we proceed here? Well, the height, you can identify it. This would be the height right here. This is what they're asking for. Okay. And so the way I will proceed is either, so I'm interested in either finding this side right here, which is XY, right? Segment XY, or across from capital Z, it's lowercase z, right? So maybe I'll use different colors to show you that I've added this later, right? So this would be lowercase z. This is lowercase x. I don't know if I talked about it in the videos, like labeling wise. Lowercase letters are for sides, capitals are for angles. I'm sure you've learned that. So technically this is side y down here. That's one way of labeling sides. The other one you could refer to is like XY or YZ, right? Like if you want to look at a side segment, right? So this is this step after this. Find side Z or side X. You can choose which one you want to go for. I choose side Z. That's what I'm going to solve for. Okay. Then we'll do our, I mean, I have to be careful here because I'm assuming you watched it, right? What can you use in this case, sine law or cosine law? Well, for sine law, you always need a pair. Right? If that should be a key word, you should be like, yeah, I remember that. A pair, a side angle pair. Do you have one? Not apparently, but since you have these two angles, you can find that third angle up here. You can find y. I'm gonna say that angle y is going to be 180 minus 46 minus 29. And that is 105 degrees. You now have a pair, sine law. You got to use sine law because you have a pair, and the 105 is up here, right? You can make an arrow just into that saying that you found that 105 there. Okay, you can highlight it. I don't know, I always like to know when I look at my work what was there and what did I add later on, right? So the 105 I found there, you have a pair. Okay, so I always start with that pair, and for some reason, don't ask me why, I always put the angle up top, sine of angle, over the side length, 6.48 inches. This is your pair. Okay, listen carefully. You cannot just do this. This is what I see often. Okay? Students forget about the sine. They just put 105 over an angle needs to be glued to sine or cosine, whatever you're using, right? You're using sine law, so we're going to have to glue it to sine. Make sure you remember that. Equals. What is it that you want to find? You want to find side Z. So we're going to match side length with side length. And the angle across the side you're trying to find is 29. So we're going to go sine of 29 goes there. Okay. Then you cross multiply and divide, right? You multiply these two, and you're going to divide going up here. This is what you're going to divide everything by. So Z is 6.48 times sine of 29. I like to use all decimals, that's why I do it this way. Divided by sine of 105. Okay. So Z is, let's type that in. Oh, I should mention that you need to make sure you see degree up here. Okay, if that's in radians, if your calculator has been used by a grade 12 student, then it will be in radians. So you got to go to mode and make sure you change that to degree. Like degree should be highlighted, right? Okay, so let's type that in, 6.48 times sine of 29 divided by sine of 105. Make sure you close those brackets. They sometimes cause issues if you don't. So that's 3.2523. That's good, 3.25 inches. So I'm going to just underline that because it's important. I box in my final answer usually. Okay. And then we'll go here and say, now cut out a right triangle. So I'll make sure the whole triangle is visible, okay? I found Z. Z is up here, right? So I'm going to cut out the right triangle that is created on the left side of the height. I'm going to cut that out. So I'm going to bring it here, here. Trust me, it's going to be a lot easier to find the height after, but I need to do a longer example with you. So the Z side we just found is 3.25. The height is unknown to us. This is also unknown, okay? Be careful here. This is not 6.48, and it's not 6.48 divided by 2 because it's not an isosceles triangle. So you don't know this, but you do know the 46 here. Okay? And if you can tell, you should be able to see it that this is a pair. Again, it's a pair because this is 90 degrees. That box is actually known to us. So you go sine of 90 degrees over 3.25 is equal to sine of 46, because 46 is across the side that we're after, which is height. Not the hypotenuse, it's the height in this case. And I'm just going to put it out there. Try it right now so it sticks. Sine of 90 is 1. Okay? It is 1. So sometimes when you type it in, you're going to be like, nothing changes. Why is nothing changing? Because sine of 90 is just 1. It's always 1. Okay? But I still have it there just so you get used to the cross multiplying and dividing. So it would be 3.25 times sine of 46. You notice that I always put one of them in brackets. That's how I like to do it. Divided by sine of 90, which you know is 1. So if you want to speed it up, you don't type in the divide by sine of 90 because it's not going to make a difference. Sine of 46. Don't mix up sine law and cosine law, okay? I see some of you setting it up like sine law, but then sneaking in a cosine in there. That's not right. And we are in inches. This is the height of the triangle. Okay? Yep. Go ahead. What would be the area of this triangle? It would be the base times the height we just found divided by 2, which is 7.58 squared inches. This is just an aside. Extension. So I will keep going on the back of this. In general, height is found by using, and I will first give you a diagram. So again, let's try to copy this triangle. We'll go A, have the height in the middle here. B, C, like that, A, B, C. That would make this B. It would make this A, and it will make this C. Okay. There are two ways of finding the height in this particular triangle. You can either find the height by going B times sine of A. So you can find, we're talking about the same height, right? Either way, but it's either taking this slanted side here, B, multiplying by the sine of A, or height can be found by taking A, side A that is, and multiplying that by sine of B. This is in general how it works every time. Because I don't want you to spend as much time as we just did finding the height. I want it to be quick, right? But just pick one, right, in general, and then you'll be fine. It works with obtuse, it works with any kind of triangle, it always works. Okay. All right. Now we're going to enter word problems here. If you ever see WP, that's word problems, okay? That's what I label my worksheets sometimes. And this is what I want you to do, right? If it's not provided, you draw a labeled diagram. Show work. All steps. Don't be skipping to the end, right? Proper notation. And units. Round final answers to 2 decimals. It doesn't matter if it's an angle, side, or angle, right? It doesn't matter. Round to 2 decimals. The book will usually do 1 decimal or to the whole to the nearest degree for angle, but try to just stick to 2 decimals. Right? Some definitions. Angle of elevation. The angle between the horizontal and line of sight looking down. It doesn't always have to be looking, it can be flying, like if you're a pilot, right? You're flying and your angle of wait. I was looking at the wrong. This is supposed to be its elevation, so it's line of sight looking up, okay? I was looking at the wrong line in my notes here. Looking up. And I'll give you a diagram as well of these. Angle of depression, it's the exact opposite. The angle between the horizontal and the line of sight looking down. And here's my rendition of this, right? If this is the horizontal here, that is going side to side, right? And the horizontal could be the ground, right? It doesn't have to be up like this, but then you have your angle of elevation goes, this is the line of sight going up, and depression, it's the line of sight going down. Okay. And just for reference purposes, imagine you're looking at a bird flying up on the sky, right? Obviously, you'd be looking up, or you're looking down at a bug on the ground or a spider or whatever, right? That would be looking down. So this angle formed here, is the angle of depression. And this one formed up here is the angle of elevation. supplementary angles. I think this one is just a review. When the sum of two or more angles is 180 degrees. Right, and so you have your straight line like here, straight angle, and you have right x, y, and z. There's three angles there, so x plus y plus z would be equal to 180 degrees, and it could be more. Okay, so I'm kind of sticking with sine law for a bit when we do word problems, and then I'll switch over to cosine law. So if you're finding, if you're like, what, right? If you didn't watch the videos, you are gonna have to catch up, right, this weekend. So here's an example. Tower of Pisa has a 10-degree slant from the vertical an observer is standing 325 feet away, and I put towards west. And is looking up to the top of the tower at an angle of elevation of 27 degrees. A, determine the length of the tower. B, calculate the direct distance between the observer and the top of the tower. All right, we're good. So we'll start with our diagram, right? And try to interpret it. So that'll be important for you to do, right? How does this work? What is this going to look like? And also be prepared to erase. A lot of students think it has to be, they have to nail it the first time. It's like, no, try it, and then it doesn't make sense, restart and redo it, right? So we've got the tower. It has a 10-degree slant from the vertical, right? So that's kind of interesting, the wording, right? So we're gonna highlight that. How is that gonna work out? The observer is standing 325 feet away. The observer is 325 feet away, and the observer is towards the west. So we even know which side of the tower this person is. And we've got our angle of elevation of 27 degrees. And the elevation tells you that it's between the horizontal and the line of sight looking up. Right? So for A, we're going to make our diagram. So if the observer is towards the west of the tower must be somewhere on the right side. Okay? And it has a slant of 10 degrees from the vertical. Okay? So if this is the ground, so let's imagine this is our ground here. Okay? The tower is leaning away like this, and I'm just gonna exaggerate, right? But this is our tower, okay? And the vertical is, there's an imaginary, it's always there, this is the vertical. Vertical is up, down, right? And we know that that is 90 degrees at that point. So if you're going off by 10 degrees, right, from the vertical, you're off by 10 degrees, then the whole thing must be right here, the whole thing must be 100 degrees, right? If you had been off by 5 degrees, then it would have been 95. You're off by 10 degrees, it's 100 in total. Yes, I get it that it's a little vague because it could have been leaning this way, right? It could have been leaning towards the observer. I'll make sure on a test that is clear, okay? For now, I just want you to focus on this, like how the wording translates to your diagram. The observer is somewhere over here, right? That's where the observer is. We're not worried about the height of the person, right? At this point, but we know that that observer from the base back is 325 feet towards the west, okay? And so now we have our triangle formed because we have the top of the tower, which we're going to go right here. We've got this point where the tower makes contact with the ground. So we've got our triangle. So I'm going to try my best. Probably should be using a ruler to connect that triangle and close it, right? And I don't know, you want to call this O, or you can call this, we can call it A, B, and C if you'd like. You know, it's good to give it letters, right? To give the corners some letters here. And the length of the tower is, they're asking for this, right? You can call that lowercase a if you'd like, or we can call this x, right? This would be x, and b is calculated the direct distance between the observer and the top of the tower. We can call this y. You could also call it lowercase c. It doesn't matter as long as you label it on your diagram. I don't really care. Okay. And then one last little bit of information is that the angle of elevation, right, between the horizontal and the line of sight looking up is 27. So there you have it. Oh, I added a C later. I'm going to do that later. A, the length of the tower. Let's focus on that. So do we have a pair, right? So you're looking, there's sine law or cosine law, right? I can tell you this, that if you have all three sides or you have side, angle, side, this is cosine law only, right? But this is definitely not the case. We don't have all three sides. And we don't have a side, angle, side where the angle is sandwiched between two known sides. We don't have that either. So you can either look at it that way, and it's like, okay, this must be sine law because this is not happening here. Or you can see a pair, and this is invisible. This one is the invisible pair. Angle, side, angle. It's the one, it's invisible pair. So this is the couple that hasn't made it official yet, right? Like they're still hiding from the masses. They don't want to admit that they're dating, right? So this is the invisible pair. All right, and so we're gonna find angle B. So find B, that's 180 minus the 27 minus the 100. So the 100, I did it probably a bit too soon. I should have drawn the whole thing so you can see it, how I got that, but I think you understand how we got the 100. So you subtract here and you get 53 degrees. Right, so this is now known to us. And so you can like make an arrow going to that. Now have pair, that's all I'm going to say. Sine law. Okay. We got to use the sine law here. It's the only thing that's going to work. It's either or, it's not both. Unless I give you a lot of information, which is not going to be the case. You're going to have to pick one to start you off. And then later we'll see how we can switch once we have more information. And so this is my pair. The 325 is across that angle that I just found. So that is what I start with. So I'm going to go sine of 53 degrees. Don't ask me why I start with the angle. That's just how, I think it's to emphasize the sine part. And then it's over 325. You can put feet down, sure, but it doesn't matter. And then what is it that I have this angle, and this angle here would allow me to find y, which is not what A is asking for. Yeah, we feel like doing that, don't we? Yeah, get out of here. Sine of 27, right? Sine of 27 over x, because that's what we want. So you got to use the angle across. It's always across, right? Let's set it up like that and now solve it. So you cross multiply this way and you divide by sine of 53. If you have a teacher next year that doesn't like this, right? No, you got to show me more steps. Just do what they tell you to do, okay? That's all I'm going to say. I don't know if in the video I did show you the long way. I can show you how to. What happened to my calculator? It's buried here. And that gives you, I'm just going to look at my key here for that one to speed it up, 184.75. And we are in feet, so don't forget your units. Always checking for that. I'm always checking for that, so make sure you get that right. So, and then B, we'll answer that here. Hopefully I'll have enough room on the side. Now we're going to start with the same pair, right? I'm starting at the same pair. If you have a known pair, leave it, right? And now I'm going to use sine of C. I'm going to use that, sorry, you can't see that. I'm going to use sine of 100 because it's going to allow me to find the side across from it that I want. So sine of 100 over y cross multiply and divide again. 325 times sine of 100 divided by sine of 53. I need to see this work, and I'll show you something that I really don't like that some folks do. It's not like I don't like you, I just don't like what you're doing, right? So don't take it personal, right? 400.76 feet. So I sometimes see, I'll show you exactly what I mean, so everybody's on the same page here. So let's say somebody starts off setting it up, and they do this, right? And then I'll just see another line going equals 476, and right, like this is actually not, this is incorrect. Maybe y is equal to that, but this whole thing is not equal to that. So just watch out for it. Don't be lazy, okay? It takes seconds, not even minutes, to add a few lines and show your work, right? C, I'm going to add this, okay? Because we just talked about height, why not? Height of tower. We're talking about the height of the tower here. And I'll make a quick little diagram again. So we've got the tower here, right? And we had this as A, this is B, and this is C. The height of the tower is measured from the top, which I'm going to make this B here, all the way to the bottom, and it makes a 90 with the ground. This is the height. That is the height. So we know that this is 27 given to us. We know that this is 100. We figured that out. I'm not going to worry about the top angle. But we now know that y here is 400.76. And we know that this side is 184.75. And now we do the shortcut. Height. There are two ways of doing this. It will be slightly off because of rounding. But you can take this side here, 400. It has to be adjacent to it. So take this side here and multiply it by sine of 27. Not 27, folks, okay? Some students try to go 476 times 27. It'll be off. It'll be a huge number. It won't even make sense, okay? So the height there is 180, That's how high it would be if you were to drop a rock from the top, right? That's the height that it would actually fall down, right? Or I'm just going to do that because you're still fresh to this. You could go 184.75, this side here, and multiply by sine of 100. I hope it works out. It will be off by a little bit, but phew, it works out. Sometimes we just fake it till we make it, right? So both give you the same height. Isn't that cool? So it doesn't matter which side you come from, right? Side times the angle that is touching it. Okay, but it's not going to work with the base, so don't ever do that with the base. It has to be the slanted going this way. Where are we at? 308. Okay, I'm going to do one more. I love highlighters, as you can tell. This and this, right? Right? Or orange. Orange, you glad it's Friday. There you go. Cheesy. There you go. Hey, I have a 9 and an 8-year-old. Those are the only jokes that I tell at home. Cheesy jokes. All right. Um, so just showing you that, right? It's on the same side and it's sine of that. Copy that down. And I would discourage using primary trig ratios. What is primary? It's SOHCAHTOA. Remember? You've done SOHCAHTOA in grade 10. Maybe not. Sine, cosine, tan. Don't use that. It's going to, 99% of the time, it's not going to work. It's only going to work with a right triangle. And sine and cosine law work with right triangles, but not the other way around. Okay. Here we have the next one, 310. So the homework is going to be, I know it's going to be a bit tight in terms of time. It's just going to be catch up and do some of the work problems that I'm going to assign after this. Also found in the textbook. So today I'm not going to go to that booklet just yet. Okay, so example, two vessels are searching for a sunken ship in the middle of the Atlantic Ocean. They both spot a ship at the same time. While being 7.92 kilometers apart. Vessel A spots the ship at an angle of depression of 31 degrees, and vessel B at 53 degrees. A, determine the distance between the ship, that's the sunken ship, and the two vessels. Vessels are also ships, but they're just used vessels to distinguish. Okay. Calculate the depth of the ship. And here some of the knowledge of parallel lines is going to creep in. You will see it. It's going to be helpful at times. Just have to make sure when to use it. I'll let you copy this first and then I'll continue. Okay, let's try to graph this. So we're assuming that, right? Like I think one thing with a few waves, we're gonna assume this is a very calm day, right? So this is the surface of the ocean, and then there's the bottom of the ocean, right? So there's the surface, it's the bottom, right? And there are two vessels that are 7.92 kilometers apart. Okay. And here you have to be a little bit, you have to think a little bit about how should I graph the rest, right? And let's call this A, and let's call this B, right? Vessel A and vessel B. Angle of depression is between the horizontal and the line of sight looking down. So a 31-degree angle is going to be, it's not going to be as steep as a 53, right? So we're thinking that the sunken vessel is a bit closer to B than it is to A. Okay, this is the ship. We're going to call this C. Oh, you can see that there. Hold on, there. We're going to call the ship C. And I mean, really, I don't care if you're off. It's just, it might help you a little bit to figure out what's what. So I guess it's here the important thing is the angle of depression, right? Angle of depression, and right, that's the 31 and the 53. Like where do they go, right? That's important. All right, so now this is a hidden pair. I can tell you already because technically you should supposed to think sine law, cosine law. Which one is it? Do you have all three sides? No, out the window, right? Do you have a side angle side anywhere? Side angle side? No, not that you know, right? You don't know the side. So cosine law is out the window. You don't have a pair at first sight, but it's a hidden pair. So ASA, I'm just going to write down hidden, right? We're going to find C using the sum of a triangle, right? Angle C is going to be 180 minus 31 minus 53. And that is 96 degrees. So it's not a right triangle, right? Because 96, it's a little bit bigger. So I now know that this is 96 degrees. Now you have a pair. Sometimes I circle a pair, okay? Pair, sine law. Okay. So we go sine of 96 over 7.92, and that's kilometers. And you have to decide what's what. We want to find both of the distances, right? So you can call this A, or you can call this X, and we can call this one Y. Okay? So if you want to find X first, you got to use sine of 31 over X, and right next to it, I'll do the other one. I'll set it up already. I'll use the pair that I already have, and I'm going to say, in this case, I want Y, so sine of 53 over Y. Okay? So cross multiply and divide. Sine of 96. So X is equal to 4.10 kilometers. If you type that in. Here you cross multiply and divide. So as you can tell, these are very similar, except for the sine of 53 here and sine of 31 there. And you get 6.36, which makes sense, right? Why this side length should be longer than X, right? If you did it right. Vessel A is 6.36 kilometers, and vessel B is 4.10, so it's a little, you have to be careful, kilometers from this ship. If you ever come across as the crow flies, that term, it just means like if you could fly right to it, across everything, across all the houses and all the obstacles, it's a direct distance to something. It just came to mind. As the crow flies, don't let that throw you off. Okay. So this is the answer A there. Calculate the depth of the sunken ship. Find the height of the triangle. So the height, I'm going to go with the letters here. I'm going to go Y times sine of 31, which is equal to, I just found Y is 6.36 times sine of 31, because the height of it will tell you the depth. And $636 times sine of 53. Yeah, did I mix it up here? Y is 636. Oh yeah, it's 31. Sorry, that's why it wasn't adding up here. 327, right? Yeah, thank you. 328 if you round it. The other one gives you 327, and that's fine if that happens. I will always make a note of that. Kilometers. below surface. I'm contemplating the homework in here or just back side. I'm going to do it on the back side of the page 125, and you were there already at one point, but now I'm focusing a little bit more on word problems and perhaps questions that you couldn't do before. Sine law only. This is only sine law, but I need you to, if you haven't done cosine law yet, I need you to go and watch that because we're going to go into word problems that involve cosine law on Monday. And then the other word problems are going to involve coordinates, compass directions. So that's going to be a little trickier. And so just be ready. I'm just going to stop the recording here for